Hi, everybody. Thank you to the organizers of this workshop for having invited me to give this keynote speech. And yes, I will focus on this talk about how we can really compute effective recommendation for clusters of tourists. So the goal is really to understand how recommender system can become more useful, more effective. The content of my talk is as follow. I will first introduce the two most important concepts in recommender system from my point of view. These are preferences of users and choices of user, and the important distinction that we have to make when we discuss these two concepts. Then I will recall you the classical view of recommender system, which is actually not making a very clear distinction between the two concepts, and is just using a generic idea of utility of a recommendation. And then really we'll enter into the problem of how to compute more effective recommendations. How we can do that, we have to better understand the user, their needs, their important criteria, decision criteria at the moment when they are making their choices. So we have to guess the utility function of the user. And this is in contrast of the classical approach, which is just trying to optimize the predictive precision of the model that is predicting the actions of the user or maybe the ratings of the user. In that respect, I will, the second part of my talk, I will discuss with you a novel approach that we have developed in the last 2-3 years, which is applied in the physical space. So when you have information about movements of a tourist in a physical place, and it's proposing a new approach for extracting this utility, the real experience utility the user are experiencing while visiting points of interest, by modeling together a group of users that have similar behaviors in order to extract from their behaviors this hidden utility function that is supposed to move, to cause their choices. Okay, so first element of my discussion is that what we like may not be what we choose. So this is the very important distinction between preferences, what we prefer, and what we actually choose. So let's consider this example. This is a Ferrari. It's a car that probably many of you will like, no? So there is a preference for this car. But actually, this is not a car that we normally buy. No, not many of us will buy this. And we will buy maybe a normal car that is sporty, but it's not that one. So maybe this red Golf. What is the goal of a recommender system? The goal is to really to understand both the preferences of the user expressed maybe on items like Ferrari, even if we will not buy this Ferrari, and also to understand the preference of the users that are derived from their actual choices. But then even to recommend something which is better than what we actually choose. So maybe to recommend this car, this red Seat, which could be better than the Golf because maybe it's cheaper and maybe it's even more sporty. I hope that I made this distinction very clear, but I wanted to stress how these two ingredients are used in recommender systems. So preferences are also called the utility of a recommendation. Should be derived because they are influencing the choices of the user, but they are hard to model and even to acquire. So we need to collect ratings, likes, or other forms. Choices that are also actions of the user, like clicks, purchases, replies to offers, bookmarks, or movements of the user, are, say, more noisier in the sense that it sometimes it's difficult to understand what is the real meaning of certain actions in terms of preferences, but they are easy to observe. So from them, we should try to guess what are the real preferences of the user. So we should predict the preferences, but in many cases, the recommender system now they're using these actions and they are just predicting new actions in a poor, let's say, would say passive way, without trying to understand what is the meaning of these actions. From my point of view, instead, the recommender system should recommend novel items that the user has not really experienced, especially in many domains like tourism, that the user will accept in terms of recommendation. So they will understand that these are good recommendations, and this is related to the expected utility. So they project in the future the experience they will make, and they will say, yes, this is a good experience to make. And then when they will make the experience, they will like to consume this item. Okay, so this is related to really choice making. So we have to understand how people are making choices and how they could use the recommendations when they're making choices. And this is related to these questions that we may have. What do we want? And also what actually we really want to achieve when we analyze the recommendations of a recommended system. Now, this depends on the effect of the choices, depends on the effect of the items that we will consume. And there are three effects or three estimations that are important in terms of the utility that these items can give. One user can project in the future and try to understand how when the item will be experienced, what will be the utility of this item. So this is called expected utility. Or when it's the experiencing the item, what will be the satisfaction of the user for this item. This is called experience utility. And then finally, after the experience of the item, the user will remember this experience and can maybe write a review or can write enter a rating that will reflect impartially this utility that was experienced. Now, these three forms of utility can and should be understood in order to build the recommended systems. And we should also, in the recommended system, try to estimate them, especially the expected utility and the experience utility. Now, how the recommended system can do these types of predictions and estimations? Expected utility is something that we can extract or derive from user online activity. So from clicks, from the dwell time on the page, the like that is expressed on an item or an option, or even from e-movements while the user is interacting with the system. And so we have an example like if Instagram is showing us an image of a destination and we like this, this is a signal that we project in this destination something that we consider as a positive experience for that destination. So this is a signal of high expected utility. Experience utility instead can be derived from user online and offline activity. Check-in, post to content, or like for an item, but when this is done during the experience of the item. So for instance, one is posting a picture on Instagram while visiting a place, so it's taking a picture and posting this picture. Remember, utility, as I said, is derived from online activity, but after the item is consumed in the form of reviews or ratings. Now, if you consider the classical recommendation model, you see that there is no distinction about that. So typically we say that there are users, there are items, and there are maybe contextual conditions. And we talk about this background knowledge that is in the form of ratings, for instance, but even in the form of, let's say, actions, a log of actions where a user has interacted with a particular item in a context. We know that there is a yes or no for this interaction. If we have rating, we have also an evaluation on a scale. And then the goal of the recommender is essentially that of making predictions for this partially known function for combination of user and items and context where we do not have explicit knowledge. And then finally, the recommender has to make a selection of the items that are shown, are really shown to the user according to these estimations, because not all the estimated items can be then presented. And typically, we present to the user the items with the largest predicted, let's say, score, utility, rating, which is not always a good idea, because then we have no control on the combination of these items. So we may recommend items that are all, for instance, very, very similar. And this is not a good recommendation set. Anyway, the literature on recommended system is really focusing on this prediction. So having the data set and making the prediction of this, let's call utility, simple idea of utility. While I don't think that this is enough, so we should focus more on the choice modeling, understanding how the user are making their choices and how we can support the users in making these choices. If we consider choices and actions instead of, let's say, utility, we do not have a much better situation. So now there is a focus on really using these observations of actions. So for instance, in a session-based recommended system, where we look at the sequence of movies that have been seen by a user. And these papers, often they say that they predict user preference when they make a prediction, but actually they are not making a prediction of preference. They're just making prediction of the next action, which could not be a good recommendation. We should really combine the two things, and we should understand that the user is probably doing something, but we also should be able to understand what is the underlying utility of this item, whether we should recommend or not, or we have to recommend some other items. Now, there are some interesting combinations of these two ingredients. And for instance, this paper was presented at Rexis last year, and it's very interesting from that point of view. Okay, so I think I made very clear my point that we should understand our user are making choices in order to support them and give, say, recommendation for items that they will be happy to choose and not regret when they would really experience that. Good. So let's consider really how the users are making choices in a travel situation. So they will use some criteria, some heuristics, some ways to decide that maybe a point of interest is interesting or not. And they may consider the cost, they may consider whether it's liked by people that are similar to us. No, and this is the heuristic that is implemented in collaborative filtering system. When it's good for the full family, for instance, if we are traveling with our family. When is maybe surprising, so we see something, an advertisement, and we say, oh, that's interesting, we never tried that. And in fact, maybe it's different from what we did last year, or has, let's say, some specific features that we tend to like, or has some very impressive features that makes these points of interest very, very interesting. Maybe is very famous or is in a place that has a very, very good reputation. Or just because we compare it with other options appears to be better than the other options. Or maybe when it's similar to what we did last year, so we are confident that this could be a good choice. Or maybe just because we're thinking that the weather will be great and we are focusing on the weather. So all of them are possible criteria. No? So, and this is something that really moves the choices of the user. The recommended system should understand that or should make assumptions about these criteria when they are generating recommendation. So really, I don't think that we can build a good recommended system by just mining, say, data sets of actions or data sets of ratings. We should better understand and structure the knowledge that can be derived from the data. So we have to make assumptions about what we can derive from the data, and not only prediction of the next movement or prediction of a rating. And we have to understand what is the current context of the user. So what could be the criteria that the user is considering when evaluating the options. Now, in order to do that, we should not forget the medium. So the fact that we are building systems that will be consumed maybe on a mobile phone or on the web, and in this particular situation will not be, let's say, just printed on a book and read in a book. So the medium is the message. So the medium is part of the message. It's not something that conveys the message. So look at this example, just to convince you that how important could be the medium. Here we have two recommendation lists. On the left, we have 3 points of interest in Florence, Italy, that are suggested, the Uffizi Gallery, Michelangelo Square, and the Duomo. And on the right, we have other 3 points of interest that are recommended. I believe, I don't know what is your knowledge about Florence, but I believe that if you look at these two lists and you have very partial knowledge of Italy and Florence, you may be more interested in the first list of recommendations. And in fact, these are the top 3 attractions in Florence, according to TripAdvisor. While the 3 points of interest on the list on the right are not that popular. They are not the top. They are still in the TripAdvisor recommended attraction, but not that popular. Now, this situation can be completely changed, or really can be changed a lot, by just modifying the images that are used. And the previous one, there were images taken from TripAdvisor. These are images that I have selected. And in this selection, I've tried to focus on the content of the items and showing that what you can do, what you will experience when you will be there. So focusing more on the experience rather than this expected that is based on the knowledge of the place. And here, probably if you look again to this list, you will think that actually the items in the second list are not that bad. And in fact, by looking at this picture, we can see that there are, for instance, the Uffizi Gallery and San Marco Museum, there are similarities. They look similar because they are actually 2 museums where you can watch some paintings and some other art exhibits. While Michelangelo Square and Santa Croce Square, there are actually 2 squares, and actually this Santa Croce Square is even probably more interesting than San Michelangelo Square. And Duomo and Santa Maria Novella are actually 2 very similar squares, churches where you will have probably similar experience. So what I'm showing here is that by just changing the images, we can change the expected utility estimation of the user, and the recommended system should understand that this is going to change when it's making the recommendations for the user. So the recommended system should have knowledge of this effect on the user when it is building the recommendations. So, in conclusion, many features and contextual factors will influence the pre-visit evaluation and also the experience when the traveler will be at the points of interest. And I just mentioned this: the knowledge of the place, what has visited, now the pictorial representation, these distinguished features of the points of interest. The travel party, that is also important, the knowledge of the app, because if the user is aware of all the functionalities of the app, will better use the app and will also trust the app more, and many other features that can be emphasized on the user interface, but actually are making an effect on the user. So there is this very variegated scenario for estimating the utility of the user and also for influencing partially the utility of the user. Now, in order to conclude this discussion, I wanted to go back to this distinction that I made at the beginning of my talk about expected and experienced utility. So what the user expected to perceive and to feel when will be at the destination and what will really experience. The 2 types of utility we said can be estimated by using different types of data. So for the expected utility, we mostly can use choice data, so choice or decision to do something. And while for the experience utility, we have to use ratings, judgment, so factually the remember utility, or actions that are performed while the user is visiting a destination. Both, let's say, types of data have advantages and disadvantages. I wanted to discuss this with you. So first of all, expected utility. I will just mention a couple of, let's say, positive aspects and a couple of negative aspects. I mark it with this plus and the minus. In terms of plus, focusing on the expected utility is something that will match the user goals at decision time, and that's positive because we have information about what are the actual user goals. And it's typically, we have a lot of these signals, so they are much less biased compared to, let's say, ratings. We'll discuss ratings after. But from a negative point of view, this feedback that we collect while the user is interacting with our system tend to be biased by classical bias of user judgment. User judgment are not, let's say, totally rational. They are influenced, as you have seen, by some even pictorial representations that may nudge the user to think something that at the end is not true. So this is something that we have to take into account. And then, as I mentioned before, we have a lot of data, but some of these data are difficult to correctly interpret. While using experience utility data, so ratings and judgments, we have again positive and negative aspects to take into account. For sure, it's positive the fact that they are explicit, so we don't have the problem of understanding what is the meaning of this assessment. And also, it's positive the fact that they are depending on the context in which the user has experienced that particular item. And so we can build the context-aware recommended systems. But from the negative side, these are data that are typically very incomplete, very sparse. They are not typically taken at random, so they have inherently some biases, bias of popularity and bias of the fact that we tend to rate or evaluate items that they like, and we don't do that for items that we don't like. And then also there is this bias produced by the fact that items are typically evaluated after the experience. And so what we remember is not exactly what we have perceived when we were at the destination. So in conclusion, my position is that we have to understand user in order to make recommendation and also in order to influence correctly the users. It's difficult because we don't know which criteria are heuristic and influencing these evaluations of the user. And the user can even do wrong estimations. So we have to build models that are robust with respect to possible wrong data that we have collected. So for instance, novel items are typically difficult for the user to assess. So if we imagine to get information about the preference of the user by showing some items that he has never experienced, we will get the wrong information. The user will not be able to say, I like this, because we'll say like only if it has a feeling that this is a good item for him or for her. And this is related to the knowledge of the place, especially in travel applications. So we have to make reasonable assumptions on the user important criteria. And this is the point, build models that are based on assumptions about what is important for the user. And then use our models in order to derive information about these utilities by making analysis of the observation of the behavior. And then we have also to convince the user that this is a good choice, which could be sometimes even difficult. Even if we have the right recommendation, the user may not understand that this is the right recommendation for him. So now let's focus on the last part of my talk, where I will present an approach that we have developed in order to cope with some of the problems that I have mentioned before. Our approach is based on an important step of clustering travelers, clustering users into cluster of users of similar behavior. This approach, so some of the results that I'm showing here will be presented in the conference next year at the Enter Conference, which is a conference dedicated to information technology and tourism. And some, let's say, preliminary results have been already presented at the same conference and at Rexis 2 years ago. The model makes use of inverse reinforcement learning and really try to group together travelers that have a similar observable behavior and optimize the recommendation for this group of users rather than for individual user. This model is also based on this understanding that behavior and recommendation should be distinct, as I mentioned before. So we have to learn how the people behave, but the recommendation should not be just following what we have learned about the behavior of users. We have to deviate sometimes from the observed behavior, because the exact behavioral model will often point out to recommendations that the user is already experiencing, is already taking, and will be not novel and will be therefore not interesting. So the recommendation should actually optimize a criteria that can derive from the observation of the behavior, but not exactly the behavior. I want to make a simple example to pass this message. In this idea of learning the behavior but deviating from the observed behavior. So imagine that we observe a user that is every day going to a bar, the Walter bar, to take coffee at 8. The recommended system should not recommend this to the user. It will not be very useful. The recommended system should maybe suggest to go to another bar, because this bar is maybe is offering better coffee and is also cheaper. So really the recommender has to understand the user is interested in Italian and maybe cheap coffee rather than that is interested to go to Walter bar. So this is the distinction between say preferences and choices. And as I said, we build this model that is clustering together a group of travelers. Let's give to you a simple presentation of this approach. So consider, say, the scenario of Florence. Actually, we have considered two important Italian cities, Florence and Rome. Imagine this user are taking pictures. So we have a database of pictures taken by users in the two cities. And imagine that one of these users has taken 3 pictures in these 3 points of interest, Pitti Palace, Boboli Garden, Uffizi Museum. This taking picture is an implicit sign of experience utility, in the sense that we take normally pictures of something that we like. Now, if we model each of these points of interest with important keywords related to the category of the point of interest and the contextual conditions that were given at the moment when we experience these points of interest, and also we use expert-defined features like whether this is a recommended item in TripAdvisor, we have a representation of an item that can be used in order to extract utility for items. Then we have to model the trajectory, and we model this trajectory with independent features that are modeling the behavior rather than the content of this trajectory. So how long was the visit to the different items? How long was let's say, the total visit to the city? How many of these items required a lot of time for visiting? So aspects related to the behavior rather than the content. And then we cluster this trajectory using these behavioral features. This is a description of the data that we've used. So we have two data sets in Florence and Rome. We have more or less the 300 points of interest in each city. And we have a data set of 2,000 and 4,000 trajectories. So a sequence of visits of users to points of interest of the cities. We have these four types of features: feature related to the context, feature related to the content, feature related to expert assessment of the points of interest, and feature related to the behavior. The context, content, and expert features are used to model the points of interest, and the context describe the weather, the temperature, the daytime. The content, as I said, describe the type of items that are visited, and the experts are related to, say, the excellence, the reputation of the items according to TripAdvisor. Well, the trajectory, as I mentioned before, is described by behavioral features that collected the duration, the number of points visited, the average dwell time in each point of interest, and how many of them are in some sense considered as relevant and interesting and excellent in TripAdvisor. Good. So we clustered this trajectory according to these behavioral features. We found 6 clusters in Florence and 11 clusters in Rome, and the clusters were computed by using a standard key means algorithm by maximizing the prediction capability of the movements of the user inside these cities. And we also discovered that there are some similarities between certain clusters in the two cities. So notwithstanding the fact that the cities are different, we found, for instance, that Florence 2 and Rome 2, which are two clusters, they load the duration and dwell time in a similar way. Actually, they load all these features in a similar way. While for other clusters in the two cities was more difficult to find similarities among the clusters. So this shows that what we learn in a city can also be used to model the behavior in another city, but requires also some attention. And then we use this inverse reinforcement learning. What is inverse reinforcement learning? Is a learning technique that is, let's say, similar to reinforcement learning, but where there is no knowledge of the reward function. So the optimal policy is learned, but is also learned the reward function, which is the utility that users are getting from the visit to points of interest. This utility is supposed to be, the utility reward is supposed to be obtained by user while visiting and depends on these features of the point that we mentioned before. So this estimation performed by inverse reinforcement learning, and actually we use maximum likelihood inverse reinforcement learning, was computed cluster per cluster. So we have a behavioral model that is specific for each cluster. And our assumption is that the users are better served if they choose, when they are in a state S, the state is being the particular points, as next points to visit, the one that has the largest immediate reward, but also will bring the user in a situation that will have a larger reward with the next choices. So this is the typical measure that is estimated by the Q function in reinforcement learning. Now, an important aspect that we have to manage in all this situation is that we have typically data scarcity, so we don't have a lot of observations. So you have seen that in our case, we have, let's say, thousands of trajectories with more or less, let's say, 5, 10 points visited for each trajectory. A state here is describing the current position of the user in the context, and as I said, the action is the decision to move to another points of interest that possibly has another contextual condition. But there are states that have never been observed in the data, no? With these states are poised with specific contextual condition. So our model, which is called the Q-base X, is generalizing when there is not enough information about the context. So for instance, if a QSA is not defined because the points of interest represented by S has never been observed in that context, then we compute Q for that state as an average of states that has the same, let's say, content feature, but possibly a different context. Or when we have a state that is representing a points of interest that has never been observed, then we compute the Q function for states that are similar to that state S. So they are representing points with similar features. And then we average the estimation for this Q function. Another important aspect is the evaluation. We should not only use precision, which is normally defined as the percentage of the next point that are in the ground truth that are correctly predicted. By the way, we use a standard learning approach, so 80% of the trajectories in each cluster were considered as a training part, and 20% of the trajectory were used as testing trajectories. And the testing trajectory were further divided into 70% that are observed in order to make a prediction for the next point of interest visited by the user. And we have this remaining 30%, which is the ground truth, what we have really observed as behavior of the user. So precision is computed in that way. So how precise is the prediction for the next point visited by the user? Reward is how rewarding are the items that are recommended compared with the items that have been really visited by the user. So if we can recommend something that could even be better than what the user has visited, which is one of the goals that we said that we have. And similarity is how similar is the points that are recommended with respect to the items that are in the ground truth. And coverage is the ratio of the poise in the ground truth that are recommended. So how we cover the actual behavior of the user. While unique is really how diverse are the recommendations among all the possible items that we can choose. Maybe the recommendations are focusing only on a small subset. And the popularity is, say, whether we recommend popular items or not. So technically, it's the ratio of these popular items that are recommended in the recommendation to the user. Good, and we have compared our approach to a strong competitor, which is SKNN, which is a session-based k-nearest neighbor algorithm, which actually is scoring very, very well, even compared with recent deep neural network models. So it's not really a weak baseline. And here we have the results for the Florence data set for the top 1 and top 3 recommendation. And let's focus on the top 1. We see that in terms of precision, we can even improve the precision of the prediction. We obviously recommend something that is more rewarding to the user by using this knowledge, because that's the big difference. SKNN is not using any knowledge; it's just let's say using the items as identifiers of something, while we are using features of these items. And the similarity is also larger, so we recommend items in general that are more similar to those that are really experienced by the user. So even if we do not recommend exactly the right item, the item should have similar features, so it should be considered as good as well. We have a larger coverage of the items that are possibly visited by the user, and also they are more diverse because we have a larger score for this unique. And also they are also less popular. So the items that we recommend are less present in these the most popular items in TripAdvisor. So what I'm showing here is the fact that it's possible to improve a model which is just using data mining by using good, say, modeling of the choice problem and good modeling of the important features for the user in computing the expected, actually the experience utility of the items. And I want to stress that really focusing on precision is not a good idea. So it's important to also understand what is the precision of our model, but it's not the most important thing. Because typically our systems have very low precision. So if we just focus on that, maybe the top one or top two can be precise, but then we generate recommendations that are typically not very good. And this has been often shown in actual evaluation with the users, where very much simpler models were performing better than very, very precise models built by machine learning approaches. Finally, what are the advantages of the model that I proposed is the fact that it's based on sequence mining. So it's using obviously learning, machine learning, inverse reinforcement learning, but it's able to make a generalization and to better understand what could be liked by the user, even if it's not exactly the item that the user has visited. And the idea of grouping users in cluster is effective in the sense that we can fix the errors of single user and choosing apparently, let's say, good items. And then the recommendations are not exactly for the predicted action, but they are in some sense action that will maximize the reward and maximize this hidden utility that we have tried to extract from the observations. And this is the end of my talk, the lessons that we have learned, and I hope I have communicated to you clearly, is this important distinction that we have to make between observe the choices and hidden preferences, or even manifest explicit preference that could even be wrong. The importance still of using knowledge for modeling preference and choices and for learning something from this observation. The distinction between what is experienced and what is expected by the user, and the importance of using different types of data in order to predict the two types of utility. And this idea that individual recommendation can be generated also by assuming that group of users with similar behavior, they are driven in their choice by a hidden utility function that can be extracted from their behavior by making assumptions on how clusters are made and what are the important criteria that are used in the utility function. Okay. Thank you very much for your attention, and I'm ready to take questions from you.